So we actually did this one whenever we were graphing derivatives. I do that as like foreshadowing for this part. If you start drawing in tangent lines, do you see how they're practically horizontal, like they're practically zero? Okay. And then they get steeper and steeper and steeper. So if you draw in this derivative, it starts out practically zero, but not quite, and then gets steeper and steeper and steeper and steeper. So what is your derivative of e to the x? E to the x. It is the best one. Also, just as foreshadowing, if the derivative of e to the x is e to the x, the antiderivative of e to the x is e to x, because we're going to do all these backwards like in the second half of the year. Fantastic. All right. So go to your bubble sheet. We're going to have this bubble be exponential and logarithmic. So we're not done with it yet. Just going to put the exponential in there right now. So d dx for e to the x is e to the x. Now, did we have the conversation in here about how I explained that there's way too much to memorize in this class and you're going to have to pick and choose what you let go? Okay. This next thing is maybe one of those things. It's not likely to be a very heavy topic, but again, I'm not going to like skip something. I'm going to show you everything to make sure that we've covered it all. If instead of e, it was a different number. So the in general format, we write a to the x. But a would be a number. So like, what if you had 2 to the x or 7 to the x or 12 to the x? Do you get what I'm saying? Like, you know that e is a number, yes? About what? So, okay, perfect. We're all on board. So it would still be itself. And then it's not a chain rule, but honestly, in my head, I kind of think of it that way. You chain on ln of whatever that number is. So if you had 2 to the x, the derivative would be 2 to the x times ln of 2. You just multiply that on. It's not technically on it, the chain rule, but I kind of think of it that way. Anyway, that's not super likely to come up, but they might throw a multiple choice in there that does that. So, all right, go back to the examples. I'm going to just do the exponential one for right now. We'll come back to that graph. We're just going to learn a rule and then do a few examples on it. So number one, f prime equals the derivative of 3e to the x is, guess what? It feels like you didn't do anything, but you did. It's just that it's itself. That's it. Number two, what rule do you need for that one? Good. X squared is the first function. E to the x is the second function. So how does product rule start? All right, the first one. All right, derivative of e to the x is e to the x. Perfect. Plus the second one, which is e to the x. Derivative of the first, 2x. Now, in this case, if it was multiple choice, they would probably factor that, okay? This is the first term, and this is the second term. What do they share in common? We're going to do GCF. All right, they both have e to the x, and they also both have an x. So x e to the x is your greatest common factor. And we're just going to put what's left once we divide that out. So what would be left from the first term? Good, just an x plus 2. Okay, just for the sake of being thorough, because in multiple choice land, they would probably factor that. All right, what rule do you need for number 3? Which one? It is chain rule. It's not just x, it's now that stuff. It's e to that stuff, it's not just x, okay? So your derivative of the outside function, that's e, it would just be itself. So e to the power 4x squared. Chain rule dot, and then you multiply on the derivative of 4x squared, which would be what? 8x. Good. Cool. Hanging in there? What rule do you need for this one? Quotient. If you remember where it starts, you're probably going to get the rest of it. So it starts the bottom, denominator. So e to the 5x times derivative of the numerator, which is just 2. Good. Minus the top. Now, that does involve another rule, chain rule. The outside function is e, so that's just itself. Chain rule dot, you have to multiply on the derivative of 5x, which is 5. All right, and then this is all over the denominator squared. Now, hold on one second, because something actually is going to reduce here. Instead of writing e to the 5x squared, go ahead and just write it twice. That's what squared means. Do you remember me saying you can't cancel these first parts out? You can only cancel if you can factor, which means they all have an e to the 5x. Well, because e is its own derivative, use another color. Do you see how there's an e to the 5x in this term and in this term and in the denominator? That allows you to cancel it. As long as it's in all of them, you're allowed to do that. So that one actually will clean up a little bit. It would be 2 minus 2x plus 1 times 5. If I made you distribute a 5, I feel like you could do that. I'm not worried about that at this point. Over e to the 5x. If I made you do that algebra, I feel like you could. Could you distribute a 5? Actually, it would be a -5. You could do that. That's algebra 1 stuff. I'm not worried about that. All right, and then here's one example of one that's not e. Okay, so it starts out the exact same. It would just be itself. And then what rule have we got going on there? Chain rule. Derivative of x squared is 2x. So that's the exact same thing we were doing. But if it's not e, you have to tack on ln of whatever the number was. And again, it's not a chain rule. It's sort of just a definition. I'll be honest with you, in my mind, I think of it like a chain rule though, because you're multiplying on. All right, that's exponential. Cool. We'll do logarithmic and then we'll do our break, right? So slide back up here. This is your graph of ln. If I start drawing in tangent lines, do you see how they're really steep, like practically vertical? And then they get smaller and smaller until they're going to almost be 0, but not quite. So your derivative graph, it's going to be really, really way up here and then come down and be almost 0, but not quite. Now, if you don't recognize that graph, that's okay, because it's actually only part of it. But I usually get somebody that's like, oh, hey, wait, isn't that, do you know what that is the graph of? It is rational. Don't draw this on your paper, but do you see how if you had this piece of it, it's your rational graph? It's just we don't have part of the ln graph over there. But it is rational. Your derivative of ln is rational. So go back to your bubble sheet and we'll fill it in. Oops. So derivative of ln is 1 over x, your rational graph. And again, I don't think this is super likely to be a very heavy thing on the AP exam, and you're going to have to pick and choose what you decide you want to memorize, but I'm going to show you everything. Let's say that they asked you for a base that wasn't e. Say it was log base 3 or log base 9 or something like that. It's going to be the same thing. It'll be 1 over x times. Now, do you see how for this one we did ln of a? You multiply on 1 over ln of a. So it's not like real hard, but it's one more thing to have to remember, which is like, do you ever get to the point where like, if someone hands me one more thing, I'm going to explode? Like, you know, so I get that. You're going to have to pick and choose. But anyway, I showed it to you. Okay. So go back to the notes and we'll try a few with the logarithm. All right. Ignore the 4 for just a second. Derivative of ln of x is 1 over x. It's just, it will be 4 over x. When there's a coefficient, it's kind of just there. Coefficients are just there. All right, what rule do we need for number 7? Good, product. The first thing is 2x cubed. The second thing is ln of x. So it will be the first thing times derivative of the second, which is 1 over x, plus, all right, what's going to come next? Yeah, ln, and then derivative of the first. But if you, see, I'm kind of a purist and mine has to go in order, but you remember how me talking about this one's really forgiving, and if you do it in the other order, it means the same thing. So yeah, that's fine too. All right, derivative of the first one, 6x squared. I'm not going to make you rewrite any of this, but do you see how in this first term, one of these x's would cancel? It would actually be 2x squared. Like, okay, thank you for heads nodding. All right, what rule do we need for this one? Chain rule. It's not product. It's not ln of x times something else. It's like ln got hungry and ate, all that stuff in parentheses. So it's a chain rule. So your derivative of ln, the rule says 1 over x, but it's actually 1 over the stuff. Good, that stuff. So it's 1 over that stuff. Chain rule dot, and then you chain on the derivative of that stuff, which would be what? 10x minus 3. Again, won't make you rewrite it, but how could you make that look nicer? Yeah, the 10x minus 3 would just go in the numerator. It would all be one fraction. All right, this would be a quotient rule. We're going to start with the denominator. So, oh, I threw trig into this one too. All right, denominator. Well, you're ahead of me. Hold on. Denominator, so we're doing a quotient rule. Times derivative of the numerator. It would be 1 over 2x. And then what? It's 1 over that stuff times derivative of 2x, which would be 2. We don't need that ln thing because it is ln. That's when you see a log base something else. But hold on, that was a little shaky, so let me make sure we're good. It's 1 over that stuff and then times the derivative of that stuff. I get that that's weird because what's going to happen to the 2's? Yeah, the 2's would cancel. So, all right, in our quotient rule, what comes next? Yep, subtraction minus the numerator times derivative of the denominator. And this is the thing you guys were all yelling at me because you have it memorized. Cosine x, good, over denominator squared. Besides these 2's canceling, I'm not touching any of that. That's no, thank you. No, good question. You can't cancel these signs because there's not a sign in this term. If it's all 3, then you can do it. Good question. All right, this is where we're going to have that weird ln thing because you see how it's not an ln, it's a log base something else. All right, but it starts out the same way. It's going to be 1 over that stuff times the derivative of that stuff, which would be what? Yeah, 20x. And then times 1 over ln of 3. So again, you just tack that on at the end. It's like one more thing to memorize. That was a chain rule. The inside stuff was the 10x squared. So that's where we had the chain rule of 20x. This is, again, not technically a chain rule. It's a definition. In my mind, I think of it like a chain rule, though it's technically not. All right, how many links are going to be in this chain? Yeah, there was. It's the 20x. We did the derivative of 10x squared, which is the 20x. This part is the chain rule. This is also going to be a chain rule. How many links are going to be in that chain? Good. What's the most outside one? The 3, okay? So what you're going to do is bring the 3 down, and it drops to a 2. Everything else stays the same. All the guts of it stay the same. Now, the most common mistake in the next part is people will still put the 3. We're done with that. We're done with the power, okay? Which function are we on next? Like, what's the next most inside one? Cotangent. Is it positive or negative? It's negative because it's a co. Does anyone remember derivative of cotangent? Good. Negative cosecant squared of e to the x. It's still that stuff. And then the third link in the chain is the e to the x. But that's the easy one because the derivative of e to the x is e to the x. You just have to remember to put another e to the x on it. So this was the 3 came down, it became a 2. Then this is derivative of cotangent. I'm really impressed you remembered it. And then derivative of e to the x. Believe it or not, that's all one term. Like it's all just being multiplied together. This is another chain rule. I'm going to start down here because it's going to be really long. The most outside function is secant. Would it be positive or negative? Positive. Do you remember derivative of secant? Secant tangent. Good. Of that stuff. So it's going to be secant of ln of 4x, tangent of ln of 4x. Secant tangent of that stuff. Now we're done with that. What's the next most inside function? ln. So what's that going to be? 1 over 4x. It's 1 over that stuff. And then the last link in the chain is the 4x. So just 4. And again, those 4s would cancel. That's what's really weird about that one is like you always end up with that stuff canceling anyway. But yeah, anyway, that's how that turns out. All right, so once again, same thing I said before. I don't know that it's super likely you'll see a problem that uses this method. I kind of hope you don't. But for the sake of being thorough, I'm going to show you just one of them. This would be a really awful function to have to take a derivative of. Do you follow me there? Like, it would be ln of all this. So first of all, what rule would that be? Chain rule. Within that would be a quotient rule. Within that would be a product rule. Like, negative fun. Okay? So here's another way you can do it. Notice I did not put a prime. We're not doing the derivative yet. We're just going to rewrite that function. Now, this involves remembering stuff from last year in pre-calc. Do you remember positive stuff is on the top, negative stuff is on the bottom, and you can take the exponent and put it out front? Sort of. You're nodding your head. Okay. So this first part would be 2 ln of x. I took the 2 out front, ln of x. Square root, it's going to be plus because it's on the top. Square root means what power? So it'd be 1/2 ln x minus 1. And then negative, because it's on the bottom, ln 3x plus 4. And then when you go to take the derivative, you can do it as 3 separate problems instead of one gigantic monster problem. So you've broken it into bite-sized pieces is what that does. It's not going to look any prettier, just let's get that out of the way right now. Okay, but it did make the problem easier because it's 3 separate things. So look just at the first one. What's your derivative of just that first part? 2 over x. Good, now we're a third of the way done. Plus sign. Now this would be 1 over that stuff, but there's a 1/2 in front. So you just keep the 1/2. It would be 1 over that stuff. Now, technically, there is a chain rule there. You would have to chain on the derivative of that stuff, but what's the derivative of x minus 1? Just 1. So you can put times 1 all day long if you want to, but you kind of wouldn't. Minus, and then it's 1 over that stuff, and then you have to chain on the derivative of that stuff, which would be 3. And you can go ahead and just put that in the numerator if you want to. Now, weirdly, the 3's don't cancel in that instance because of the plus 4. Yeah, so like, I'm a hands-off person anyway. I'm just like, leave it alone. But anyway, we made it 3 separate problems. I hope they do not give you one like that, but if they do, that's how you do it. All right. What is 14 asking for? Equation. So you need point and a slope. What's the x part of your point? E squared, which don't discriminate. That's a number. It's 2.718 squared, whatever that is. Okay. We're going to plug that in. If you plug in e squared to the 3rd, be e to the 6th, good. And then ln of e squared. ln and e cancel, so it would just leave you with 2. When you do ln e squared, just be 2. So you actually just end up with 2e to the 6. So we just took e squared. Let me like recap that. We took e squared and plugged it in. There was just a bunch of stuff that canceled. So 2e to the 6. Slope comes from derivative. What rule do we need? Good. Product rule says the first thing times derivative of the second. So this is what we're learning today. Derivative of ln 1 over x is rational. Plus the second thing times 3x squared. Good. You guys are so good at this. This is awesome. All right, and then we're going to plug in e squared. Now, what is this really going to reduce to? You have an x cubed divided by an x. Good, so that's x squared. In your mind, think of that as x squared. If you plug in an e squared squared would be e to the 4th plus, now if we plug in an e squared there, ln and e cancel, so just be 2. And oh goodness, e squared again would be e to the 4th times 3. So 3e to the 4th. What does that give us? This would be what? 6e to the 4th plus another e to the 4th. It's 7e to the 4th. Okay, as by way of a pep talk, the hardest thing we did there was 2 times 2 and 2 times 3 mathematically. It looked really weird, but mathematically that's the hardest stuff we did. All right. So here's your point and here's your slope. They look like alien-ish, but go with it. It'll be y minus what? 2e to the 6 equals 7e to the 4th, parenthesis. Beautiful. It looks awful, but again, mathematically 2 times 3 is really the hardest thing we did. And squared means to the 4th. Okay. So typically, these are worth at least 2. And it's a point for getting this and a point for writing the answer. So if you forgot to write this answer, but you had the 7e to the 4th, you would get 1 out of the 2 is typically how they do it. Okay. Occasionally, in a situation like this, when the derivative is really weird, they'll make it worth 3. So it'll be a point for the derivative, a point for the slope, and a point for the equation. So in that case, if you made it there, you'd get 2 out of the 3. Try to remember to write the equation, but yeah. All right, and then our last bubble, go back to your bubble sheet. We're going to do inverses. Now, I don't write these as a rule. I can show it to you if you want, but it looks awful. I do it by way of an example because an example makes sense. What you're going to do is make a table. So you're going to have x, f, and f prime, and then you're going to have your inverse. Do you guys remember how this little -1 means inverse? Okay, unfortunately, the notation for inverse derivative is that it does -1 and then the prime means derivative. I don't like it either. Sometimes they'll just call it something else. They'll say the derivative is g and then you'll have f and g. You know, so that's nice when they do that. But I'm just going to make up an example. Can you guys give me some single digit numbers? We'll just make one up. All right, say you had 2 and 3. The way an inverse works is you would take 2 and 3 and reverse it. It'll be the other way around. And then give me a number that's not 2 or 3. Let's pick something different. 7. Okay, so if this is 7, your inverse derivative is 1/7. And that's your answer. I can write out the rule if you want, but it looks horrible here. This is what it looks like. An inverse derivative is 1 over the derivative of, so you have to look at my paper to do this. Like, anybody? Yeah, no, so yeah, exactly. Anyway, you just flip it over. It's the reciprocal. Just draw some charts. All right, let's try a couple. Would I put 2 of these on here? Let's try 2 of these. So it's saying find the inverse derivative at 6. What you're going to do is go ahead and set up your tables. And I actually kind of like this because it's sort of like a scavenger hunt. You're just looking for all the missing things. So you just fill in the blanks until you find the one that you want. I will say most of the time I have seen with these ones, they give extra information that you do not need because they're trying to trick you. So I see a lot with these, they'll give you extra points that are not necessary. They give you extraneous information. All right, so we want the inverse derivative at 6. You're gonna have to just watch me point to this because it's just these tables. That means whatever lands in this box is your answer, and we want to plug in 6. So that's your starting point. Cool so far? Okay, now if 6 goes here, where can I put a 6 over here? Good, perfect. Okay, you're still with me. Now that allows you to set up a problem. You take this and set it equal to 6. Okay, good. And then it's welcome back to Algebra 2 class. What do I call that? Evacuate, evacuate. Move the 6 over. And then factor. So what's that going to be? 2x and 1x. 6 would be, let me think what we need where. The 3 would go here, 2 would go here. 1's going to be negative and 1's going to be positive. We would want -4 for the 2's and then +3. So you actually get 2 answers. What would this one be? -3/2, and then this one would be 2. If you read back through the directions in the problem, it actually tells you which one to take. It says you want the positive one, so we want the 2. Okay, so 2 goes here. 2. We filled in one more box. Where else can I put a 2? Yeah, now that is not really necessary, but I do it just to be thorough. Okay, we found the point. Go us. Now we need a derivative. So we're going to find f prime. This is like finally some calculus. What's the derivative of this function that they gave? Good, perfect. 4x minus 1. Don't forget about the 1. And then here's, that usually all goes beautifully. Do you plug in a 2 or do you plug in a 6 to this? 2. For this chart over here, your x is 2, so you're plugging in 2. All right. 2 times 4 is 8. Minus 1 is 7. And so your answer over here, 1/7. Weirdly, it's the same as the one we made up in the example we did, but it's not always going to be 7. Okay. Let's try one more. Set up your charts, tables, whatever. I very strongly dislike the notation f inverse prime. Does that bother anyone else? Like there's a -1 and a prime mark. You're all just like, we're cool with it. There's so much weird notation. I don't know, I don't like it. Four is the number we were given. Where can I put a 4? X on which one? Yeah, the right side. We want the inverse. Whatever we get here is our answer. We want the inverse at 4. And then 4 goes there. That allows you to set up a problem because you can set this function equal to 4. I'll be honest with you. I might just guess and check that one if it was me. What's going to work there? No, I guess not. Can you guess what that would come out to? I'm trying to think. Oh, well, I guess we'll have to work it out. I'm trying to think in my head what it would be. I was trying to save you the work. Anyway, would 3 work? 3 squared is 9. Oh, well, let's just work it out. You would have to multiply the x minus 1 to the other side. That would give you 4x minus 4. Is it going to be 2? Oh, yeah, you're right. Because if you were to factor that, I was trying to save you the work. Yeah, because that's going to split x minus 2, x minus 2. All right, good, 2. My brain wouldn't do that for some reason. I was trying to save you the writing. If you can guess what it is, you can guess and check. 2. Okay, now I need a derivative. What rule do I need? Quotient. All right, denominator. Derivative of the numerator. Minus numerator. Sorry, I ran out of space. Oh, what's the derivative of the denominator? 1, good, over x minus 1 squared. We'll try again. And it's hard. Are you going to plug in the 2 or the 4? 2. Good. You're plugging in the 2 to that because it's going to give you the answer for this box. All right. So if we plug in 2, 2 minus 1 would be 1. What would that be? 4 minus 4 over 1. So 4 minus 4 is 0. So this comes out to be 0. Say that a little louder. Then your answer is undefined because you can't flip 0. You can't divide by 0. Think about the unit circle. You know, whenever you end up with something that's a 0 and then you try to flip it, it's undefined.